Okay, we did the law of sines on Friday and law of cosines today. You're going to use it when they're side, 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 or side, angle, side. So you can find angles or sides with the law of cosines again. And here's your basic law of cosines equation that you're going to write down. And just so you guys know, I adjust it when I write it down for when I put it in the calculator. But that is your basic law of cosines. When you look at the equations, it looks like there are 6 different equations, but once you memorize one of them, if you notice, if you're looking for side A, B and C are the other 2 sides, so you only use the one side that you're looking for to start the equation, and then everything else happens, and you'll see what we're doing. So it's not that there are 6 different ones. And what they call the alternative form over there, I need to explain what's happening. So okay, so if you take your basic law, and you don't have to write this down, just follow along with me. If you're going to find side x, you have to, or excuse me, if you're going to find the angle, is what we'd be doing for this alternative one. I would line it up so that its partner side would be called x. We talked about that with law of sines, what partner sides are. So I have to bring a squared over, I have to bring b squared over. And we would subtract them as we brought them over. And what I want to do is leave the angle behind. And so we will divide now by negative 2ab on both sides. Now when you look at this stuff, the x squared minus a squared, b squared, negative 2ab, there are a ton of negative signs in the formula, right? So one of the things that I would do mathematically is I would take that negative sign. Now remember with fractions, it can be on the top, the bottom, or even out in front, right? And the fraction's negative. So I'm going to take this negative sign, and I'm going to bring it up here, which means the a and the b that are negative now become positive, and the x, which was positive, now becomes negative. And if you look at this formula, there's only one negative sign in it now. And then I go a step further whenever I do this. I do my angle is equal to, and I do the cosine inverse right away over here. And then I'm going to do this for you guys so you can see it easier. So the idea is whatever angle you're looking at to find using law of cosines, if you know all 3 sides, you can find any of the angles. I suggest you find the largest first. And then what you're going to do is pick out the side that's partnered up with it. And that's the only one you subtract up top, and that's the only time you use it up top, and that's the law of cosines. The hardest part about typing this in is you have to be careful with your top and the bottom of the equation if you type it all in at one time. We don't develop the law of cosines, so let's look at an example problem quick. Again, I just throw down, I don't worry about what it looks like. I'm just going to draw a triangle, call it ABC. They're telling me little a is 11, little b is 5, and angle C is 20 degrees. In geometry, we call that side angle side. I knew 2 sides and the included angle, or the angle where those 2 sides come together. So I can find x. To find x, that's the law of cosines. It's on the left-hand side of your page. I shorten it up even more. I take the square root of it right away. I'm going to take the two sides that I know, 11 and 5. I square them. Doesn't matter what order I wrote those two down in. Could it be 5 squared plus 11 squared? Right? So order will not matter when you're adding them up. Minus 2 times 11 times 5. And again, whether you write down 11 times 5 or 5 times 11 won't matter. Cosine of the included angle or the partner angle 20. So notice that these two things are the ones that are partners. So if I'm looking for side x, I need to know its partner angle, right? The nice thing about the law of cosines compared to the law of sines, I think, just type it all in. I can just go ahead and hit the square root. Go ahead and clear it. So, I can just go ahead and hit the square root. We had 11 squared. Nope. 11. No. I can't see my buttons on this thing. I wish it showed up. 11 squared plus 5 squared minus 2. Now you can put parentheses in. It's easier just to hit times 5 times 11 cosine of 20, right? Technically, you close the cosine and you should close your, I guess on mine I don't have to close the square root. But. So we're getting about 6.5, 6.53 you might write down. Now, once I know 6.53 here, what can you find? What's next? Then we should go to angle A or angle B. One of the things that you have to remember and it's a little more difficult because you may end up using some of the numbers that you're finding in a problem right away. What would happen if I found angle A using law of sines right now? I'd be using this angle, right? This side and this side. If I use angle, side, side, what could I be doing? Well, I could be running into the ambiguous case that we talked about on Friday, right? Where maybe it's not working. Maybe there is only one, but maybe there is a second, so you'd have to be careful. So today is a law of cosines day. I'm going to do law of cosines whenever I can, just so you guys know. You would have choice there, but when you only have one angle and you have choice between law of sines and law of cosines, I would use law of cosines. Because where does inverse cosine produce answers? Remember that? Where does inverse cosine produce answers? Yeah, where? In quadrants 1 to 2, right? Which would be any angle that's between 0 and 180. So the law of cosines does not have the ambiguous case with it because it can produce any angle from 0 to 180. Acute angles in first quadrant, obtuse angles in the second. When you do the law of sines and you do an inverse sine, it can only produce answers in quadrants 1 and 4. So it can't produce anything that's more than 90 degrees. So let's just say 11 is the largest side, right? Is it possible that angle A is obtuse? Does anybody know that it's not? If that's obtuse, let's say 100 degrees, and you do the law of sines, it's going to give you 90 minus 10. It'll give you 80 degrees because it can only produce 0 to 90. So what it's really giving you is the reference angle of 80 degrees. So if you go to 180 and back off 80 degrees, you'd be at 100. So you have to be very, very careful when you're given all this information. Anyway, I'm going to find angle A next. And this is how I write it. I go right into the cosine inverse formula. Some of you might want to stick with the regular formula, and I'll show you what it would look like in a second. If I'm going to find angle A, 11 is the partner, so I do have to use 6.53. If you're not sure you got it right, I don't know what to tell you. But 6.53 and 5. 6.53 squared plus 5 squared minus the 11 squared. So the partner side is the only time it's used. It's subtracted up top. Then we're dividing by the two sides. So all of that goes inside the law of cosines. Now some of you might want to write that down as so depending if you had an Algebra 2 teacher, you might have always written it like this, and then subtracted the squareds over, get the answer on the calculator, divide by -2 times 6.53 times 5, and then inverse your cosine. You can do it either way. When you go to the calculator, I do it this way, and so I go second cosine. I have to put parentheses now, additional parentheses around the top and the bottom. So that first parenthesis that pops up is for cosine inverse. So we're going to do the top, which would be 6.53 squared plus 5 squared. Those two are positive on top. And I'm subtracting 11 because that's the partner side. Now I have to close my numerator again and divide by another set of parentheses, 2 times 6.53 times 5. Close the bottom, and then technically you have to close your cosine inverse. And when you hit enter, I'm getting 144.8. 144.8. So if this is 144.8, what's my missing angle? Angle B is 180 minus 20 plus 144.8. What do you get there? What? 15.2. So that would be finding all pieces of information here. If you did the law of sines back here for angle A, you would end up getting 54 degrees doing the law of sines, because it would give you a reference angle, because that is an obtuse angle. So you have to be very, very careful. Questions?